Hi everyone, let's take a look at problem 6. You're studying meteorology and collect weather data for Gainesville, Florida for the months of April, May, and June 2018. The function t of x is equal to 0.18x plus 80.25 gives an estimate of the daily high temperatures during this period where x is the number of days after April 1st, 2018. Evaluate T of 26. Well, you would plug 26 into your equation. So 0.18 times 26, 0.80.25, and you would get 84.93 degrees. So you just plug it into that equation. Part B says, select the physical interpretations of T of 26. Well, let's go back to what it says about this equation. It says x is the number of days after April 1st, 2018. So 26 days after April 1st would be April 27th. So we want April 27th. And this function, the function t of x, gives an estimate of the daily high temperature. So that means the daily high temperature would be approximately 84.93 degrees on April 27th. So T of 26 is the estimated high temperature on April 27th. So it would be part 2. Number 7, a manufacturer wants to design an open box having a square base with sides of length x and the surface area of 144 square inches. What dimensions will produce a box with maximum volume? The function that expresses the volume in terms of the length of the side of the box is this equation. Part A, what are the reasonable values to use for x? In other words, what is the domain in the context of this problem? Well, let's see, x is the length of the side of the base. And since the domain talks about the x values, the domain would really talk about the length of the side of the box. Well, we know the smallest x value that we could have, or the smallest length of the side of the base, would be 0, and we can't have a negative number. We really can't have 0 because then we wouldn't have a box, but anything bigger than 0 would have a box. So I would say from 0 on up to, and then we're just kind of guessing here. If I look at this equation, we have 144 minus x squared. Well, if we have 1 squared, that we'd just be subtracting 1, or 2 squared is 4, so we'd be subtracting 4. 10 squared is 100, so we're getting closer to the maximum. 12 squared is 144. So 144 minus 144 would be 0, and 0 times anything would be 0, so our volume would be 0. So I would say the largest x value that we could have for the largest side of the box would be 12 inches. So 0 to 12 would be some reasonable values for x. Part B, find the value of x which has the maximum volume. So go to our calculator here, turn the calculator on, clear out the old equation, and then now I need to type in this new one. So parentheses around the numerator, so x, and then times parentheses 144 minus x squared, and the 2 parentheses, and then divided by, I could put parentheses around the 4, but I really don't need to because it's just one number. Now I want to find a good window, so I come in here, and the reasonable x values that we came up with was from 0 to 12. So my x min is 0, my x max is 12. And then I do zoom fit. So zoom 0. So the graph goes up and then it comes back down, and it wants us to find an X value that has the maximum volume. And so we want to find this maximum point. And if you recall, that's under calculate. So we need to do second trace. And then maximum is option 4. And then it wants us to go to the left of that top point. So go to the left and hit enter, and then to the right and hit enter again and a third time. And it tells us the maximum X value is 6.928 and so on inches. So the side of the box would be 6.928 and so on inches. So that would be part B. Part C wants us to find the maximum volume. Well, remember the equation was volume is equal to all this, so that's our Y value. And so our Y value is 166.276 and so on cubic inches. Okay, please take a look at problems 1, 2, and 3, and then watch the next video.